So another way to measure spread is to find the interquartile range. I hope the words interquartile range bring back good memories of quartiles, quartile 1, quartile 3 from box plots. Right, yay! So you remember the minimum value, quartile 1, median, quartile 3, and the maximum. So the interquartile range, or IQR, is actually the middle 50% of the data. From box plots, we already know that quartile 1 marks the first 25%, or the 25th percentile, and quartile 3 marks the 75th percentile. So all we have to do to find the IQR is subtract quartile 1 from quartile 3. So if these were the actual values of this box plot, the IQR would be 133 minus 130, because this is quartile 3, this is quartile 1, and so the IQR would be equal to 3. Finding IQRs are also helpful because they help find outliers. Unusually small values are found by subtracting 1.5 times the IQR from quartile 1. And here's the calculation for that. 130 is quartile 1, and you subtract 1.5 times IQR, which is 3, which we already found, and this happens to equal 125.5. And this means that values lower than 125.5 are outliers, but not 125.5 itself. That is not an outlier. So based on this, you can probably guess how to find the unusually large values. They are found by adding 1.5 times the IQR to quartile 3. And here's the calculation for that. 133 is the quartile 3 value, and you add 1.5 times IQR again, and then you get 137.5. So values higher than 137.5 are outliers, but 137.5 itself is not an outlier. Basically, everything outside the range 125.5 to 137.5 is an outlier. Since there are no values outside this range from our box plot, there are no outliers in this dataset. If there was an outlier, that outlier would be represented as a dot, and the minimum value would be moved to the next lowest value that was not an outlier, or the maximum value would be moved to the next highest value that wasn't an outlier.